All right, so I just broke the video up into two pieces in case you wanted to look at my first few problems, go try some, and then come back and look at some other ones. So I do have some more problems that I do want to work out with you to make sure you have plenty of practice on these because I'm sure this may be brand new to you. So here we go. I have sine x times cosine squared x minus sine x. Again, I got my Pythagorean identities handy. I got my reciprocal identities handy. It's all about taking these, making it simplified as possible. So you want to do that by trying to change all of your problem into one trig function and by using these identities. So I'm actually going to factor out a sine of x. So this term has a sine x in it, and this term has a sine x in it. So it's kind of like the greatest common factor that we did way back when in math. So they both share a sine x, so I'm going to factor that out. When I take away the sine x from sine x cosine squared x, I'm left with cosine squared x. When I factor out the sine x from sine x, nothing's left there, but we can't just leave it. So it's automatic cosine, it's automatic 1. So I took everything out. So the beautiful thing about this, if you were to take 10 seconds and check yourself, it'll give you the original problem back. Sine x times cosine x is sine x cosine x, and I left my 2 off. Sorry about that. So if I were to multiply sine x times cosine squared x, I get this original term. And if I were to multiply sine x times negative 1, I'd get negative sine x. So far so good, hopefully. Now, if I look at this, this is super, super close to something that I need. So clearly this is the one that I'm working with. So if I were to subtract cosine squared x from both sides, that would give me 1 minus cosine squared x. So that means that these signs are the opposite of what I need. So if I were to work with this first one over here that I'm starring, if I were to subtract cosine squared x from both sides, that would give me a positive 1 and a negative cosine. This is a negative 1 and a positive cosine. So I'm going to factor out a negative so that my sign on the inside is all the same. And that way I can make a substitution. So this time I have negative cosine squared x. And we have a positive 1. Now, this is exactly what I need, and that's a plus sign, pretend. So now I'm going to make this substitution. This is now equal to sine squared x. And make sure that you are writing these down in your notes and things like that, so you have plenty of examples to look at. So this is now equal to sine squared x. So again, I use that first Pythagorean identity. I use this one up here. And I subtracted cosine squared x from both sides. So I made a substitution. So I got 1x on the outside, and I got 2 on the inside. So my final answer, you properties of exponents, you add them. My final answer is this. And let's not forget our negative. So this is our final answer. So we only use one Pythagorean identity to help us simplify this problem. So we factored out a sine x. We changed our signs because they were off by negative 1. And then we just multiplied. All right, let's move on. I got 2 more that I want to take a look at. Okay. Tangent squared x plus 1 over 1 minus sine squared x. So this one, we are going to be using, might be a combination of Pythagorean and reciprocals. You kind of just want to look and see what you have. So if you notice on each slide, I have my Pythagorean identities and I have my reciprocal identities. They're there to help me as a reference. So as you're working on your assignments for today and tomorrow, keep those handy as a reference. So this top section, tangent squared x plus 1. So my numerator definitely looks like I need to be using this one over here. So I can replace 1 plus tangent squared x with secant squared x. So I'm going to go ahead and make that substitution. All right, so that's my numerator. And the denominator, this is 1 minus sine squared x. So that means I'm working with the top Pythagorean identity. And that is going to be cosine squared x because I subtracted sine squared x from both sides. So my denominator now gives me cosine squared x. Now I can do a few more things. Hopefully you recognize that secant and cosine are reciprocals of each other. So let's fix our denominator and make it be our numerator. So I'm going to bring the numerator down. I'm doing nothing with it but re-copying it. All right, and I can change cosine squared x using my reciprocal identities, and it's going to be this one here in the middle. Cosine of theta is equal to 1 over secant theta. So cosine squared must be secant squared. Now this turns into a division problem. When you divide fractions, you keep the first one and take the reciprocal of the second, and it turns into a multiplication problem. So this problem simplifies to secant to the fourth of x. And that is our final answer. Again, down here in this section right here, when you are doing dividing fractions, so when you're dividing fractions here, you keep the first one, you change the multiplication, and you take the reciprocal of the second. So I did like a keep, change, flip kind of thing. And last one, last but not least, I got one more. Okay. We are going to simplify 1 minus sine squared x times secant of x. So this one here, we've seen this quite a few times in the problems that I've gone over. This is our first Pythagorean identity. And 1 minus sine squared x is equal to cosine squared x. And secant x, just for the moment, we're going to bring it down. Can't really do anything to it just yet. I'm going to bring it down. That way I'm not doing too many steps at once. Now the cosine squared x, I'm going to bring that down and make that cosine squared x. And the secant of x is going to be 1 over cosine. So reciprocal functions are coming into handy here. So I use this one down here. So the secant of theta is equal to 1 over cosine of theta. So I made a substitution. When you multiply fractions, you do top times top and bottom times bottom. So the top is going to be cosine squared. The bottom is going to be cosine of x. We saw this earlier in a problem. I have 2 cosines on top and 1 on the bottom. So 1 is going to cancel. And our final answer is the cosine of x. And just like that, we've gone through and we have done some practice with Pythagorean identities and reciprocal identities. So hopefully you find them kind of maybe in the middle, not too hard, not too easy, but just a bit enough of a challenge.